So can you just confirm like you're able to see my screen?
Yes, can you put it in presentation mode?
Yeah.
Perfect.
Yeah. So hi, this is Rohan here. So we will start lab 2. So basically it will be deployment of core network with VPP UPF. So there are two objectives of this lab is like we deploy 5G CN with VPP UPF, and then we will try to understand how it's different than the previous lab that we did with SPGT Utiny. So before moving, like what is VPP based UPF? So the name VPP, it says it's a vector packet processing. So as you see in the diagram on the right hand side, it's a vector of packets. So it's the multiple packet. It's a batch of packets that are processed at once, and there are different nodes for the each functionality. Let's say GTPU encapsulation, GTPU decapsulation nodes, or for example lookup nodes, which will do the lookup for routes. And for each node, the packet batch is processed parallelly. So we have some optimization and the high performance behavior over here. Then this VPP, it supports DPDK. So we have some acceleration in the user plane. And so this is about the VPP. And then there is another project called UPG. You will also see the links on the down. So UPG is the plugin which is written on top of VPP. It's a release 16 compliant plugin for the UPF. Uh, yeah, as I said, it's the performance is a better. We tried to do some benchmarking with VPP. So here we took 3 server in Massive. We have core network deployed. In Obelix we have VPP UPF, and in Asterix we use some traffic generator, which Gnode BSIM or some script to generate GTP traffic. So here we have not enabled DPDK. So we were just trying to push some traffic with the help of the Ethernet NIC. So we are able to push around 5.2 Gbps with a packet size of 1024 bytes. So this is like it's not yet the finished experiment. We can go beyond this also. Then for the DPDK, the experiment is ongoing from our side, but some of the people from the community, they have tested with DPDK also. Like someone from AWS, they have deployed with a DPDK and they are able to reach around 1.8 Gbps. Of course, it's not satisfactory, but it's a good start. And of course, we will see some optimization and good traffic throughput results. Then
you say DPDK, when you say DPDK on AWS, you are using ENA adapters?
Yeah, right.
Okay.
I think we will take question later because we have just 2 minutes left for the presentation. Sorry. Uh, yeah. Yeah, so just overview like how it looks like. So we have all core network components and the VPP UPF. So I just wanted to focus on the VPP UPF box. So you will see there are two IP addresses, like one is in red and one in a blue. So how it is implemented, it's like it's a software switch. So we need to bind the interfaces of a container or physical machine to the software switch, just like OVS. So that's why we need some virtual Ethernet pair, and the one pair points to the software switch, and one pair points to the interface of a container or bare metal machine. So in your network also, whatever like IP address which terminate with 202, it means it is the IP address of web pair in your setup also. Then yeah, so just final thing, so I just talk about VPP, I just talk about UPG. Then what is difference, like what OAI has built on top of this VPP UPF. So we have done this couple of things. We built Python NRF client, which able to register to NRF, and then SMF can use this information to discover UPF. Then we have supported GTP extension header also, which required for the 5G user plan. Then we have also also added a feature of traffic steering. So there are a number of ways to support traffic steering, like with auto header creation or redirect information or using forwarding policy. So for this implementation, we have used forwarding policy. And last is we have added some build instructions which used to integrate with our 5G CN. Just recap about lab. It's the same lab as the previous lab. You will do in three parts. You will deploy 5G CN. You have to wait. You have to check everything is healthy. Then you deploy the RAN simulator like GNW SIM. You wait. You check your UE is connected, and then you will do some traffic test. And I have shared the link of slides. So the last slide, I have some exercise for you. So when you progress in the lab, you have to try to find out or understand answer of these questions. So it's a very simple question. Maybe question 3, you have to think a bit. Yeah, so I'm done.
Yeah, I'm ready now. So let me share my screen.
Yeah, let's do the network slicing. So that function that we'll talk about is still private, but we will make it public certainly next week. So let's go ahead, Tin.
Okay. Can you see my screen now?
Yes,
Tin. Yes.
Okay, so welcome to lab 3. So the last lab of the core network section for today. So the main objective of this lab is to show you the overview of network slicing in 5G core, and also show how the OAI 5G core network supports the network slicing feature. The idea is go through a very simple deployment scenario with multiple slicing instances to serve different UE. So first of all, thanks to Saga and Rohan, we now have a very basic knowledge about OAI core network deployment and component. So it we make life a lot more easier for us for this lab. So for a quick overview, network slicing has been identified as a crucial enabler for providing a flexible and cost-efficient approach to realize the service-oriented 5G vision. So in the network slicing, we allow us to deploy multiple logical network to be created on top of the common shared physical infrastructure. So basically, multiple network slice instances will be created to deliver the same features, but for different group of UEs and services. A network slice is identified by a single network slice selection assistant information, and this information composed of a slice service type or SSD and a slice differentiator or SD. Maybe someone need to be mute. Okay. So for the OAI core network, we plan to fully support network slicing related procedure according to 3GPP standard by relying on two main procedures. First, with the help of an SSF, the AMF instance will be selected according to the request slide information from UE and GNode B, it rely on the AMF reallocation procedure, which will be available by the first quarter of 2022. Then the appropriate SMF UPF will be selected to serve the corresponding slide by using the NRF services. For now, OAI can support network slicing per UE and per PDU section. And you can see in the figure below, UE1 has two different PDU sections belonging to two different slides, while the UE2 have two sections belonging to the same slide. So let me briefly explain how the OAI core network support network slicing from a practical point of view. the first step is to design the network by configuring the network function with the corresponding parameter. In this lab, we will provide you the predefined YAML file. Then you can use Docker Compose to instantiate the network manually, or use a management or orchestrator such as open source manual or Geomatics to instantiate and onboard the network function. Then when the UE attached to the network, based on the policy of the UE, it provides the list of the requested network slide information to the AMF via the registration request. If the AMF cannot serve this UE with the requested slide, AMF reallocation procedure will be executed to find a suitable AMF. You can see here the AMF tool, for example, and then let this AMF handle the UE via the interaction with the NSSF and run entity. So when the UE establishes a PDU section with a data network, the serving AMF tool in this case may need to find the appropriate NIF by querying the NSSF with the requested slide information. Then the AMF via NIF service can discover the appropriate SMF and send the N11 message to create a new PDO section. So you can see here the SMF one. Similarly, SMF can discover the appropriate UPF so that the user plane can be set up between the UE, run, UPF1, and the DN. So in this lab, as a very simple scenario, we will deploy two network slices in which a common AMF and NIF will serve both slices. And due to the limitation of the GNodeB SIM that cannot support multiple UE with the same GNodeB at the same time, we deploy two different GNodeB instances with two UE. Then each UE, we establish one PDU section belonging to two different slices. For example, slide number 1 with SSD 128, and slide number 2 is with the SSD is 129. I also want to mention here that we use SP gateway US UPF for slide 1 and VPP UPF for the slide 2. And you can see here that the figure of the network topology of the deployed network with my account. So you can see here all the IP address of the AMF, SMF, UPF, and DN also. But of course, with the account, we have a bit different IP address. The IP address will be very useful when we need to distinguish between the slide number 1 and slide number 2. So with this lab, we first deploy 5G core network with the predefined YAML file, and then we deploy two GNodeB with the GNodeB SIM, and then we can verify the log, and then you can see it's very similar to the lab 2 and lab 1. So now let's move on to the lab section.